Welcome back to our second AI Policy Forum Symposium. Thank you for being with us this afternoon. For those of you just joining us and who weren't here this morning, I'm David Edelman from MIT's Internet Policy Research Initiative and the AIPF team, and I'll be your host for our discussions this afternoon. Now, this morning, we heard from researchers, academics, parliamentarians, policymakers, and more about some of the most pressing cross-cutting issues in AI policy, both how we think and act concretely and architect AI laws, and also what we can expect in auditing and monitoring AI systems. Now, especially when they're being used in the systems that we need to trust. Now, for our afternoon sessions, we're going to turn to two areas in which AI systems are in broad use today. And we're going to be creating a dialogue that aims to be as policy relevant as it is robust. And so first, we're going to start with healthcare. To do that, a session called the AIPF Wide Reach, which is a series of sessions focused and convened on that topic, assembled experts devoted to AI, policy, and health from around the world to discuss important issues of data sharing and privacy, specifically in clinical AI. In January 2020, the session's organizers, Professors Marzyeh Ghassemi and David Sontag of MIT, Zaid Obermeyer of UC Berkeley, together with the Jameel Clinic and the Internet Policy Research Initiative, convened a group of AI health policy experts from academia, the nonprofit sector, government, and commercial services, spanning a whole range of disciplines that included computer science, medicine, law, and anthropology. And drawing on that wide-ranging conversation, what you're going to hear today are the presentations from the organizers, along with their panelists of the findings and the recommendations of that session. Now, we have some fantastic panelists to present those findings. They include Jonathan Sellers of the UK Biobank, who's going to be covering nonprofit and government success stories and limited access models. Anna Goldenberg from the University of Toronto is going to be covering upside demonstrations. Marcy Wilder from Hogan Lovells is going to be covering legal frameworks, regulation, and funding. Douglas Fridsma from DataVent is going to be covering technical approaches to privacy. And finally, Elliot Green from Dandelion Health AI is going to be talking about infrastructure and data sharing. The panel then will discuss the recommendations of the session and, as always, invite your audience questions. So start thinking about your questions now. And when you're ready, at any time during the panel, please feel free to enter them into the question and answer box that should be right at the bottom of this video screen. And so with that, I'm delighted to introduce one of the co-conveners of these forums, Professor Marzyeh Ghassemi. Marzyeh, over to you. The floor is yours.
Thank you so much for that introduction. I'm going to go ahead and share screen, but you won't see too much from me before we get into the real content here. So as David said, I was co-convening these wide reach sessions, and we had a really fantastic group of individuals who helped present on the technical and policy content. You're going to hear from some of the people today that will summarize each of those sections. So there were wider sections that had a group of panelists that were experts in many areas present on specific topics, including nonprofit and government success stories, also limited access models, covering the upside demonstrations, what we can do well when we actually get access to data and work as machine learning researchers, the legal frameworks, regulation, and funding that's involved in a lot of these processes, the technical approaches to privacy, and finally, infrastructure that's required or necessary or convenient for data sharing. And so you'll have one panelist that presented in these larger sessions summarize these findings for you. And this is quite a tall order. So we're very, very appreciative of our panelists taking this time to go through and present all of the findings that came out of these really intense discussions that we had just a few months ago. Then we're going to show some of the recommendations from the report that was summarized from all of these different findings and discussions. And we'll have a panel discussion that we moderate, first with a couple of questions from my co-convener, David Sontag, and then we'll open it up for audience Q&A. I also want to remind you that the reason that we convened this really was to understand what can be done to decrease barriers to access high quality healthcare data and to advance more innovative, robust, and inclusive research results while being respectful of patient privacy. The way that we did this previously was in each of the sessions, we had a speaker present on a topic of expertise. Then we had concrete policy approaches that we wanted to propose that responded to these challenges in these different sessions that were being discussed. And so the findings and the recommendations that you'll hear from in just a moment are part of a written summary that the larger AIPF team helped us prepare that has some of this discussion and policy proposals. with that, I'll stop sharing and I'll ask our first panelist to take us away. Jonathan.
Thank you very much indeed, David, Marzyeh, for the introduction. And there we go. I thought I would give a real life example of data availability and sharing in practice. There's a resource in the UK which has got 500,000 consented participants and is available to any researcher anywhere in the world of any type, commercial, academic or charitable, and it's generated so far about 30,000 registrations and about 4,000 published papers. It's got a very comprehensive record of phenotypical data, health records, genetic data from genotype to exome sequence, the whole genome sequence, and imaging data on about 100,000 individuals. In return for using the resource, researchers have to publish their findings and return their results. So how does this actually work, and how do we actually encourage this type of sort of endeavor? I think the main thing is to do it and get on and do it, and do it well, which means set it up right at the start, because if you get it wrong at the beginning, it's quite difficult to correct it going forward. And then others will actually follow the example that's been set. I wouldn't wait for government's changes and regulations. I just try to work within the existing framework that's there and essentially deliver the scientific results, because that's ultimately the demonstration credibility for what's behind it. And the key factors in this are essentially the ability to de-identify all participants, to be transparent with what you're doing, to communicate how your resource works, and to communicate with your participants about what's happening, and certainly latterly really the use of data platforms. I've got just some brief examples of how this really translates into AI research. We've seen a significant year-on-year increase in AI applications applying to use the resource, and in reality trying to actually analyze some of the, particularly the actual scans and the genetics inevitably involve some form of AI. And we've had a lot of publications on really the use, particularly from the retinal fundus images, which is the image from the back of your eye, about various risk factors which have been identified, some known, some unknown, from the work which has taken place. The key with AI is to make sure that the training data set on which the AI process interface works is made available, so that others can see that it actually is repeatable, and to also ensure that the process interface is available too. This doesn't mean that a researcher has to disclose intellectual property behind what they've actually developed. It just means that the thing has to be able to be used so that other researchers can come along and effectively conduct a suitable peer review of what's gone before. So the key issues that I would identify in doing this is essentially do it. The best demonstration of data availability is of scientific effectiveness. Share, and actually share all your best practice methods. We're very happy to be imitated. We've managed to share a lot of what we've done over 6 of the 7 continents. Antarctica is yet out of reach, but we're working on that. We also make it easy for researchers. Our process starts, it's 2 to 3 months from beginning to end. We try to strike a fair bargain. We don't try to take people's IP, and we try to put forward a fair agreement so that people don't spend a lot of time trying to negotiate it. In terms of the musts, it's really de-identification, which is completely pivotal in all this, particularly with the advent of modern technology and modern social media use, because that really essentially is the thing which protects the confidentiality and privacy of the participants. And I think that transparency and communication are extremely important. As we've seen really in the UK and the EU, if you lose the confidence of participants and patients about how their health data is being used, it makes it much more difficult for governments and the authorities to actually make this sort of data available. And lastly, really the use of technology. I think that the advent of proper cloud-based platforms with sort of research access interfaces is very much the way forward. It stops downloading data. Our data set runs to 15 petabytes, and so that's quite tricky to actually download from one part of the world to another. And so really the use of these sort of platforms is definitely the way forward, and also allows a much more auditable trail of researcher activity. So with that in mind, I'm going to hand over to Anna. Thank you very much indeed.
Thank you, Jonathan. I will share my screen.
And as we wait for Anna to share screen, I'll remind everyone that you can and should submit your questions below the video screen at any time.
Thank you, everybody. And I'll dive right into it because there are a lot of lessons learned from the upside demonstrations. Just to remind everybody, here we focused on the AI projects that have actually already been deployed or in the process of being deployed elsewhere. So this is not a research endeavor. This is sort of AI coming to life in healthcare. So there are many successes. Researchers starting to have access to large and diverse networks such as Providence that was in presence, and Nightingale Project and UK Biobank, but these are still very individual efforts. So we need more of those. Having a common infrastructure and people who have enabled and provided a common infrastructure to these multiple projects and AI effort, both development and deployment, are much further ahead. So we need to think as a community and as a policymakers to how to strategize around this. What we have seen in terms of impact is incredible. Implemented AI helps to guide policies, to efficiently spend resources and prevent economic downfalls. For example, one of the projects that was presented was administering tests in Greece at ports of entry with limited resources and making it efficient. And the research have shown that it actually increased the likelihood of sampling the right people and having the right view of the whole population. And the policies have been changed dynamically throughout COVID and lockdowns and prevented some of the lockdowns. We are starting to use more and more data to make decisions. There are full images. So in the case of cancer screening, breast cancer screening, Regina Barzilai has shown that we can achieve much greater successes by looking at full images as opposed to the summary statistics. There are millions of individuals that were explored in several other projects to make inference for policy purposes. Continuously updated models is something that people think are in the future, but they are starting to be used in practice. And again, back to the COVID in Greece example, and another example that was presented about updating emergency department census models during COVID. These models are being updated in real life and not just sort of like software where it's has been tested, locked, and then it's used in perpetuity. So this is a different mode, and it's an exciting time to be using this. The economic analysis from several examples have shown that millions of dollars and countless lives were saved already due to the several examples that were presented at the upside. And this is something that we can attribute to using AI, which is very exciting again. All of the projects that were presented are collaborative efforts. There are many different experts in the loop, including physicians, including nurses, including IT and etc. So a great diversity in what makes it AI in healthcare a success. And it was also shown in one of the projects that, including fairness constraints, actually helped to bring more equitable healthcare to some of the minority populations, in that particular case with the mental health conditions. And again, this is something that we would like to strive for. Of course, with many successes, we know that only a few such successful cases have been implemented, and that means that there are many barriers that we still have to overcome. A lot of times we rely on existing data, and in a lot of studies, enrollment is often skewed towards either privileged populations or large populations. And when we are developing tools for screening, which aim to capture the full population, that means that we have to do extra work with the tools. We are hoping that there will be more equity in terms of enrolling such patients, so that the AI tools would make it easier to become more fair as well. there are evaluations. Sometimes the constraints keep changing, and that makes it difficult to sort of design the ongoing tool. There's important information that is stored in such a way that is hard to make full use of. So we know that important information is stored in notes. It's often used, but it's sometimes difficult to make it used in a sort of the structured and full way. There are a lot of times right now in terms of AI implementation, we have to establish this interpersonal relationships with the heads of the hospital to ensure that, and the IT departments to ensure that there will be support for the tools. This takes a lot of time. There are also no standardized pipelines that would say, these are the steps that you have to go through to deploy your model. And this is something that I will mention later. The standardized frameworks I will also mention later. We really, as a community, have to come together to consider what a standardized framework for evaluation of the tool and of the impact of the tool should be. Again, when we want to use AI tools in principle can be used across a great variety of hospitals and healthcare systems, but each of them have a completely different setups, which makes it difficult to integrate new tools. And this is something that I think we should also create policies for, that there will be more synchronization for the AI tool integration. There is a concern from the community that because there are so many readily available ML tools that are available, it's that anybody can just pick it up and do it. And one of the projects, I believe Regina Barzilai has shown what is achievable by a person who doesn't know machine learning deeply, and what is possible to be done by a person who is a true expert in machine learning. And the accuracy went from 57% to 91% in case of an expert. So we still need to have the ML expert in the loop to scale it up broadly. I will hurry up because there are a lot of barriers, and again, a lot of them are about the standardization, which I will mention on the next slide. A lot of the machine learning, so for the machine learning community in general, a lot of the machine learning work that's done and that's published is not done with the implementation in mind. And so the design that is used for evaluation of these tools and saying that these are good tools to use in practice is not the design that of the use case where it will be used. And thus the performance when it comes to the usage in the wild is much lower. And so we have to start thinking and start encouraging our community to design evaluations to be appropriate for the use cases where such a tool could be used. And of course, in healthcare, we depend a lot on great many things, including the infrastructure and data collections and data processes. So to keep investing in this space, AI cannot do everything; can only do work with what is available and the data that we have access to. So there are a few suggestions of what to do, and I think there will be more proposed. I will wrap this up quickly. The biggest one here is what I've already alluded to, is the need to develop standards. And the standards are both on the technical front and not. So training and testing, we are working with very rare conditions and very rare problems. And so we need to have a standard in the community of how to address it properly. The fairness constraints, there's a huge benefit to that. Evaluation of both the performance and impact. privacy and data sharing. So when we say that the data is de-identified, some of this is not possible when we are trying to give the insights back to the clinician who is treating that particular patient. And so what is necessary and what is feasible to have the highest impact for the AI to be able to make the highest impact in healthcare needs to be addressed. There is a great need for what happens after an AI tool is deployed. So right now, we sort of stop the conversation at deployment because it's already a lot of work, but we need to consider of what monitoring tools need to be in place in terms of capturing deterioration and what happens next and how they will be updated. So, and how they will be passed to the IT departments and hospitals and other places. So finally, I would like to conclude with a message that we think that there's a great potential for AI in healthcare. We think that the successes have already shown that it really can have a transformative impact. And what we need now is to think about how to scale it up. So these standards, I believe, will help to scale it up, but also appropriate training for the users. And the users include both sort of the medical workers, clinicians, but also patients. How do we do this knowledge transfer? How we pass this information? I think all of this is important for the near future and to start working on that immediately. So thank you very much. I don't know how long I took, but this was a very intense session and a great many examples, and I hope I gave it some justice. Thank you.
Thanks, Anna. Marcy, go ahead.
Good thing. All right, so I'm going to talk today about the legal frameworks governing AI and healthcare, and because it's relevant to a lot of what was just said about standardization and access to data, and what are the data sets that that we need and that will be most useful for moving healthcare forward. So in terms of legal frameworks and regulation, it's a complex landscape, right? The current legal framework governing the privacy of health data in the US alone, so I'm not even going to talk about GDPR, Europe and the rest of the world, includes HIPAA, the Common Rule, the FTC consumer protection laws, FDA, state general privacy laws, health privacy laws, state consumer protection law, and genetic privacy laws. And this legal landscape is filled with uncertainty, and it leads institutions, particularly those that hold clinical data, to be quite cautious in how and when they share it. The enforcement risks around privacy in the health sector are real, and the rules are complicated. And so, we've heard a little bit about clinical data and the hospitals that hold them and the lack of standards. Well, there's a lack of standards on the privacy front as well. And I think that those hospitals and health systems that have clinical data are quite conservative in terms of how they share them. But there's also self-generated health data from Fitbit and the Apple Watch and increasingly other kinds of devices. And the companies that hold that data, which tend to be technology companies, are a little more risk tolerant. And so that data might be more available. But again, the goal, I think, in many instances is to combine it with clinical data, which is less available. I think there's a whole nother category of genetic data, which is held by a mix of labs and consumer-facing companies, because there are an increasing number of direct-to-consumer genetics companies. And they have a mixed risk profile, but I think there's going to be an increasing focus on making some of that sequencing data available. And then there's other kinds of consumer data, often referred to as social determinants of health. That's financial data and educational data and other kinds of consumer purchasing data that are widely available for things like marketing and advertising. But I think that there is certainly an increasing pressure to try and take some of that and combine it with health data. So look, the convergence of clinical data, genetic information, self-generated data, consumer data, these are all governed by different and overlapping laws. And those data sets, to make those data sets available for AI, to develop those AI algorithms, to use AI to improve population health, even in this complex landscape, there are pathways, and some of the pathways that we discussed are de-identified data. Those methods and technologies are evolving, increasing use of synthetic data. And I think we're going to see, there's Mimic and others, but I think that we're going to see the growing availability of synthetic data sets, limited data sets, which bake privacy protections into contracts essentially, and give access to a little bit, not quite identified, but a more robust set of de-identified fields. Individual consent, IRB, waivers of consent. And there is not a plan or a coherent approach to rationalizing this legal and policy environment. We know the benefits AI can bring to healthcare. We've talked about many of them today, this morning. We also know the privacy risks are real. And some of the potential harms we talked about in our session were discrimination and public shaming, blackmail, medical identity theft, and soon in the United States, in the case of abortion, potentially criminal prosecution. So what do we do? How do we increase, how do we balance? You know, the NIH is a major funder of biomedical research, and they have the ability in the US to set policies for funding and pilot their own programs directly to enable health data access. And there is a fair amount of work going on at the agency in modernizing the ecosystem to help create data sets, including combined data sets that can leverage AI in more effective ways. But it's slow going and it's under-resourced, and it's not a major area of focus. There's not a political drive to make that yet a major area of focus. And so I think in the short term, researchers are going to need to get better at using the pathways available, some of which I just outlined. And there needs to be, I think, more of a concerted effort at developing a rational privacy framework that draws lines, won't be perfect, but will balance the risks and benefits in a way that allows technology to take us forward in meaningful ways. And so I'm sorry I don't have a better set of, and we didn't develop in our group a better set of policy proposals on how to take this forward, but I think that I would look forward to working with groups like this in terms of really starting to flesh out that framework. And I know we're going to talk more about that in the Q&A. So I will stop there and pass the baton.
Thank you, Marcy. Doug, go ahead.
Okay. Well, first of all, I want to thank everyone for the opportunity to sort of participate in this forum. I'm going to try to very, very quickly go through some of the technical challenges that came up in our particular groups. And I want to sort of talk about technical challenges, the private sector, and then I think really how many of these solutions are all going to have to come together. So when it comes to some of the technical challenges, there are a lot of trade-offs that have to be made. There are trade-offs in privacy-preserving linkage technologies in terms of matching fidelity and the re-identification risk using probabilistic or deterministic approaches. There are also trade-offs between differential privacy techniques that pit patient privacy against the unique value of the data. So for example, genetic information, if one of the solutions to protect privacy is redaction of personally identifiable information, redacting genetic information and eliminating that particular sequence renders the data essentially valueless. And so there's a lot of trade-offs that have to be made, both with regard to match fidelity and the value of the data that's provided. There really is a need for neutral solutions. I like to say there's never going to be one ring to rule them all. And it's going to be very, very difficult if we want to have comprehensive data sets that can be linked together to create neutral solutions that can work with just about anyone than to have walled gardens. Similarly, data enclaves, although that's an important aspect of the privacy and security challenge, creates isolated silos of access. And so if everybody says the way to access our data is through our data enclave, it limits our ability to link data across different kinds of data sets. And that actually then gives you sort of a limited view on the patient. There's the inadequacy of safe harbor as one of the methods to protect data with novel data types. For example, the genetic information is one that safe harbor doesn't really lend itself to. The alternative, of course, is expert determination, but there's a limited number of experts who can do expert determination. And things like the baseline frequency of common genetic mutations and other things like that make it harder for expert determination to use statistical methods to determine the re-identification risk. When it comes to private sector challenges, what we see is that a lot of private sector research is starting to outpace academic communities. This has to do with access and funding. So for example, we can look at things like Amazon or Google or AWS, all of which are using their enormous data sets and their enormous resources to actually start to outpace academic communities. While that can advance certain kinds of research, it is somewhat problematic if a particular company with a particular perspective or business opportunity are the ones that are leading a lot of this research. And we have to figure out how to make this more open. There are financial incentives for data providers that benefit commercial customers. So as people recognize the value of their health information, these are hospitals and other groups, they sometimes are reluctant to share that with the research community because they see that if they aggregate this data, they may be able to actually get additional money and resources by aggregating and selling that data to interested commercial consumers. Now, I would also say that there's part of the research community that is also needs to be important. We need to lead this effort. And even among the research community, when we think about data sharing plans as part of NIH grant funding, we've not always led the way with our ability to share. Although data sharing plans are a requirement of NIH funded grants, it's not a scorable element. And if the research community wants to actually drive improvements in how we safely share data and preserve privacy, let's use the academic approach and gradually get better and better insight in how to do that. And finally, public good is often an afterthought for this data. It's often behind hedge funds and big companies, and the use of that data for public good is oftentimes an afterthought. We've seen some successes with the COVID work and groups of individuals coming together, sharing their data to help us understand the pandemic. But that's a rare exception that has happened recently. And the concern, of course, is now as the pandemic begins to move into a different phase, people are going to withdraw that participation and we'll be back to where we were before. And finally, solutions to solve these problems are going to require a multiple-pronged approach to make that happen. It means that we're going to come up with privacy solutions that help us balance those different trade-offs. Those may need to be linked to certain kinds of data enclaves that limit access, but still allow linking to occur into those enclaves. We need policies and incentives that are aligned with the public good and what the research community requires. And it's been mentioned before that there needs to be shared infrastructure that helps with this privacy as well. The final thing that we determined was that education is going to be important, and this is across the board. We need researchers to have better education about the importance of preserving privacy and some of the modern techniques to do that. We need more people trained in expert determination, ethics, data use agreements, and regulations to make sure that everybody follows the necessary regulations and are compliant as they roll out these technical solutions. So with that, I'll hand the baton.
Fantastic, thank you. And our final panelist is Elliot.
Hello, one moment. Okay. So firstly, thanks for the invitation to be able to participate. I'm excited to share some further details on the data infrastructure portion. as many before me, what I'll try and do is represent the thoughts of all the members of the panel. So firstly, I'm going to start by highlighting the work that my colleagues Dawn and Anthony presented on in terms of technical infrastructure. I'm then going to highlight another important but sometimes unappreciated point, the infrastructure needed to align incentives of those who own the data with those who want to use the data.
Elliot, I think we're seeing the wrong screen. We see the Google Doc, not the slides.
Apologies. Thank you very much.
And as a reminder, for those who are here, please, you can and you should submit questions below the video screen at any time. And that looks great, Elliot. Go ahead.
Thanks. So as many before me, I'll try and summarize, the thoughts of the members of the panel. Firstly, we're going to talk about the work that Dawn and Anthony presented on in terms of technical infrastructure. Then going to highlight another important but possibly unappreciated point, the infrastructure needed to align incentives of those who own the data with those who want to use the data. Without this, even the most elegant technical infrastructures will fail because it won't contain any data. Now, in terms of this particular infrastructure, so Anthony is the Chief Data Officer at the Broad Institute, and he and his team have built a modern approach to data infrastructure with a transition from traditional to cloud. By being cloud-based and centralized, it addresses some of the main considerations of legal and ethics neatly. Legally, by keeping the data accessible but not downloadable, there's far less risk as to what is being done with the data. It also allows for more control in terms of the types of use cases people are engaged in, since you see the activity on the platform if necessary, which also allows you to ensure the ethical concerns are minimized. The advancements in cloud computing and security are the backbone of what has made this possible by giving peace of mind to the data owners. Also, the flexibility of the system means you can keep updating the security elements with the latest advancements. For the data users, there's the ability to access a modern data stack and any tools required. The plethora of available tools that are cloud agnostic helps to ensure a smooth process regardless of which tool someone may have used previously. The slight downside as of now is the cost of running compute compared to running compute locally. But we hope that there's a continual decline in cloud compute costs. That issue should be outweighed by the benefits of accessing the data. Now, this is Dawn, the professor of the Department of Electrical Engineering and Computer Science at UC Berkeley, and she's illustrating the model whereby individuals and perhaps institutions feed their data into a more decentralized model or data depository. Users of this data can access whatever they need to train on through a data storage list. This is clearly a vision of the future, and one where the data generator has the ability to decide on whether to share their data or be reimbursed for it. There remains the natural challenge of aligning incentives for the data generators, as well as the obvious technical challenges, but it is a future I think we can all get behind, and one where patients have far more involvement in their healthcare and associated data. Now, in terms of something that we really focus on, that's the technical infrastructure. And this presentation normally would deal solely with that. But we kind of forget an important point. Someone needs to agree to release the data from wherever it lives so that it can get into whatever technical infrastructure we've actually built. This is where Dandelion focuses. And then, to be honest, we kind of borrow liberally from the Broad's architecture for the technical components of data storage and deployment. For example, negotiating to gain access to data amidst all the operational and strategic objectives that a health system has is a difficult task. And we must ensure that we create platforms that mean that the usage of the data and subsequent products and tools benefit all the parties. Historically, we've seen far too often that many organizations look to acquire data and then divorce the data producer from the process of tool development from that data set. And in fact, we believe this is exactly where the data producer is most useful, and we should be encouraging structures where they play a vital role in developing any tools or research to ensure that the products or research components that are created are of benefit to patients and providers. Ultimately, all actors want the same outcome, which is to utilize AI in order to create a much more effective care for patients. And so therefore, all boats must rise for this to work. For context on this slide, Dandelion is a product development platform for clinical AI. And we've partnered with hospital systems to extract all of their clinical data, de-identified and tokenized as per Doug's previous presentation, and have placed it in a centralized cloud environment where we facilitate researchers and AI developers to investigate the data and build effective tools. we found that we couldn't just solve the problem of how we would store and distribute their data. Though this was a key consideration, we ultimately needed to address why they would want to share it with us in the first place. And so Dandelion's approach has been to partner with healthcare systems, which we think has been the key to unlocking the power of their data. We created a model where they would benefit equally from their data being utilized for research or app development, as well as gaining streamlined access to new technologies far faster than previously was allowed for. And ultimately, everyone would like to see patients and providers benefit from the advancements in AI. And we hope that addressing both the incentive and technical challenges create a pathway to a far more collaborative future.
Thank you. And thank you again to all of our panelists. This is really fantastic. So I'm going to, in favor of making sure that we have enough time for robust discussion, I'm going to very briefly summarize 2 slides of our recommendations that will be found in our report. And these are really around 2 things. And the first is we need to make more data available for research use. And as you heard from our panelists, some of the recommendations that come from these findings are we need to support growing research data sharing communities. We need to update regulations to promote data sharing. You need to enable easier access to safe harbors like HIPAA has for de-identification. We heard about many positive examples. We also want to expand funding for private health institutions to create data sets. There are many good examples of this in the public sector as well. And if we have public-private initiatives that create new data sets, that's great because it means that there's more open opportunities for research on health data. And finally, we think it's very important to expand the requirements of data sharing and reproducibility in publicly funded research projects. There's been some effort in this recently from the NIH, and they're using the leverage that comes with this funding of research projects. And then the second thing is not only do we want to expand the data that's available, we always want to remove barriers to data for researchers. So some of the recommendations that came out of this were decreasing barriers to research and development on this federally created health data. You know, if this is data that should be accessible because it's funded by some federal entity, we should make it more easily establish the steps that are going to be part of gaining access to that so that it's a more inclusive and equitable set of research opportunities for all. We think that training programs for expert determination of de-identification really need to be funded. These are a big bottleneck right now in releasing more data sets. And finally, we need to have a careful look at the ethical principles that govern data sharing. And there already are many proposed principles around this. Obviously, you can't satisfy all levers or buttons at once, but we think that this is a trade-off that's very important to think through intelligently. With that, I'd like to transition to my co-organizer, David Sontag. Do you want to take us away with some questions?
Sure. So thank you everyone for your presentations. I wanted to go one by one through several of the recommendations that we gave based on our findings and kick off a conversation around what led to them and what the next steps might be from a policy perspective. So I'd like to start from a technical infrastructure perspective. We heard from many of you about the move toward cloud platforms as a means of securely sharing health data for health AI research and development. And so I'd like to dig a bit deeper into why a data enclave and a cloud platform and what some of the challenges around that might be and how that should inform the future development going forward. So Jonathan, if I recall correctly, this move to a cloud platform is very new for the UK Biobank. Could you comment a little bit about what led to it?
Sure. I mean, really, when we started off in 2012, making the data available, there wasn't the alternative of the cloud platforms didn't exist at this stage. And I think we've realized over the course of the last few years that the scale of the data is such that it's simply not possible to transport around. And it's not particularly sensible either, because for a researcher to be able to get access to the entire sort of 15 petabyte database requires absolutely massive investment in infrastructure from them. And so that's just a duplication of investment, which is unnecessary. So it's much easier for researchers to actually come to the data on a cloud platform. the cloud providers as such are hugely incentivized to make sure these platforms work, their security is really good, and that they're scalable. And it's much easier for us to actually really sort of, we try to sort of be a sort of big brother on this, but just to make sure that researchers are doing what they say that they're doing, because their activities are much more transparent in a sort of really in a cloud platform than they are if they've actually got access to the data in their own system.
So then could you talk a bit about how the logging works and what the restrictions are? So for example, on the cloud platform, could someone download a large chunk of data to their computer? If not, how would they be able to sort of get off the cloud platform the research results that they would need in order to publish a paper or deploy a new technology?
They can download sort of a lot of the phenotypical data, but we put a sort of restriction on downloading the sort of more extensive genetic data. That's the exome sequence data and the whole genome sequence data and all that, and really the imaging data, simply because it's just not practical to do so. And we're trying. I mean, the idea behind it is that there's a research environment in which they can upload all their tools, all their research. There's no restriction on that, and it's much easier for them really at the end of the process to simply almost sort of press send when their results are available. Because what we want back is we want them to publish what they find in an appropriate journal, and we want them to return their results to us so that we make them available to everybody else. So another researcher can come along and actually effectively peer review what sort of research that they've done and on what data.
So I'd like to hear from the other panelists as well in terms of what you see as some of the criteria that one would need for a successful cloud platform versus what some of the limitations might be.
I'm happy.
Go ahead, Anna, please.
You go ahead.
Yeah, I'm happy to chime in. So from the perspective of the presented methodologies that were already deployed, none of them were developed on the cloud, if I remember correctly. That said, there is a push from a lot of the healthcare systems to move to the cloud. And so I feel that this is the trend that where the deployment is going as well. And so I think the biggest impediment to downloading it and to sort of developing AI successfully is that generally when people have full access to their data on their big GPU farm, they can run a whole bunch of things simultaneously. They can play with the data in a way that that fits the models and that allows for the most efficient exploration. I think the biggest concern from the developers of AI is that it might, if it's not an efficient process for development and exploring the data, that the students, for example, might get frustrated and move on to other projects, right? So I think there's a convergence to happen here, which I think that the cloud platforms do provide all of these guarantees that Jonathan has talked about, which are important for AI researchers as well. We just need to make sure that the rules and regulations around how the data is accessed are such that they allow for this efficiency and sort of transient model development as the researchers are used to, because efficiency creates best products.
So David, I'm going to weigh in with a slightly different perspective. If I have my 3 billion base pairs on a USB drive and I leave it on a train, it's not identifiable because nobody's going to know what those base pairs are or how they're connected to me. What actually creates a risk for re-identification is when those 3 billion base pairs get linked to socioeconomic status or other kinds of data sets that then can become identifiable. It only takes 60 to 70 SNPs to be able to really sort of pin down who somebody is. One of the advantages of cloud is that it prevents people from downloading and then using that data to link to other resources. And so by being able to kind of put a wall around that, if you will, and then bring the computation to the data, it actually helps to reduce not just the immediate risk, but the downstream risk that data that leaves that cloud environment actually can be linked or used in ways that increase a re-identification risk.
I think that's a really important point that you're making, Doug. And Anna already spoke about, I'd say, some of the software challenges. I've heard tons of complaints from my own students about going into these data enclaves and not having access to the right Python environments, the right database environments, and so on. But I'd also like us to think about and talk about the computational cost. So for example, to use just 2 of the state-of-the-art GPUs, graphics processing units, where a lot of the state-of-the-art machine learning is being done today on AWS would cost my lab, my research group, over $60,000 per year. Whereas if I were to purchase this using an academic discount from an NVIDIA GPU, I could spend an aggregate cost of less than $10,000 per year for the same compute resources. So over a factor of 6 difference, which is substantial from an academic perspective. Now, I saw that UK Biobank, in partnership with AWS, is providing over $500,000 per year of credits, particular to low and middle income or resourced researchers. But I think even for well-resourced researchers, such as perhaps groups at places like MIT, we still can't afford those high costs. So what do we do? Anyone on the panel can take that.
I think right now, if I can speak for sort of the ML community, David, as you can, right now the cost for developing the types of models and the scale of model exploration and selection is a bit prohibitive on a cloud without sort of special arrangements, even for well-funded researchers. I would second what David said, but I'm hoping it's sort of converging to become cheaper and more affordable. But that is a necessity for especially data that is very complex and very large, images, anything like that requires a lot of compute.
So let me just ask a question of Anna and David. Are there reproducible data resources that would allow, say, the equivalent of what NCATS funds for the CTSAs to provide research support for clinical trials, that they could do the same sort of thing for, say, research on data and machine learning and AI? The question is that if every researcher has their own Python environment and everybody is sort of one off from the other, then there are no scalable solutions in which you could provide centralized funding to make that happen. And the risk there is that without sort of a concerted effort to solve that, we have to make a trade-off. And if the trade-off is around privacy, that becomes particularly problematic, because should there be significant breaches in the clinical side of things, hospitals pay millions and millions of dollars in fines when that happens. One can imagine similar kinds of things may happen in the research community if we're not careful with the way in which the data is being used.
Yeah, I'd like to just kind of add a little bit to Doug's point, and maybe this will come back to what I presented on a little bit from the Dandelion perspective to add to that, is that it's very hard to imagine as we go forward this arrangement of a large number of kind of smaller data sets being continually allowed to leave health systems, kind of in this slightly unsupervised or decentralized manner. I think people are starting to get concerned of exactly what Doug is talking about, which is what if my data is where? And so there's a much larger trend towards this idea of, at least if we put it in a centralized cloud environment, we understand where it is, we understand what's going on with it, we can police that better. And I think hopefully, David, the next part is to say, okay, well, we really need to encourage from this a way almost for maybe the private sector to start, subsidizing some of the more research behavior that occurs, because in the context of the investment that's going in from the private side, I think the research investment is quite small, but the benefit is very clear. So hopefully as that starts to become more of an ecosystem, I think people will appreciate the idea of incentivizing more research behavior and perhaps subsidizing it more. But it's very difficult to see a future where it's not cloud-based, just based on some of the concerns that people have who own the data.
Okay, thank you all for your responses to that. I know there are more thoughts, but I want to move on to a different topic. So we spoke a bit about, at least with regards to US regulation and US law, that there seem to be some conflicts between US federal law and state law about what's allowed for private sharing of health data. Marzyeh, could you give us maybe a concrete example of such a conflict and your thoughts on what a path toward reconciling that would be, and perhaps what is already being done? Like, are there already cases in courts today which are working towards that?
Yeah, so I think that I will give, why don't I stay on this de-identification topic? Because I think it's a hugely important one. And de-identification is one of the pathways, and in many cases, the most viable pathway to making data available. And one of the reasons I think things evolved that way, and one of the ways in which I think the HIPAA regulations actually helped quite a bit, was by establishing a federal standard for de-identification. Two methodologies: one, a safe harbor, which is very easy to use, remove 18 identifiers, and pretty much you're done. And everybody knows what those are. And I think that has enabled a lot of data sharing. There is a second methodology by using a statistician and getting a certification that certain data sets, or even sometimes it can be the methodology, results in a de-identified data set. And I think that's very important for research and some of the cloud-based efforts that we're talking about, because where you have the cloud-based data and a certification, you can, one of the things that the statistician can take into account is anticipated recipients. And so where you really limit access, you can have a more robust yet de-identified data set. I think in terms of the state laws, we're seeing states actually move in a direction that is undermining that federal standard. And I'll give the example of California, although California was the first, but my guess is not the last to do that. And what California did is it created for California a similar but different de-identification standard. And in a very confusing way, right? It sort of it exempt certain kinds of HIPAA data. It didn't exempt others, and then there's a whole bunch of health data that's not covered by HIPAA. And for that, in order to be considered de-identified and mitigate some of the liability risks, there need to be additional steps that actors need to take. For example, if an institution is going to sell de-identified data sets, that would need to be put in a consumer-facing or patient-facing notice of privacy practices. So you need to add that. I'm going to talk about whether or not that's a good idea in a moment. But in addition, it requires certain contractual restrictions and prohibitions on re-identification when an entity discloses that de-identified data set or makes it available to others, and then it imposes some downstream contractual requirements, again, protecting against re-identification. Now, having contractual requirements that prohibit re-identification and providing consumer-facing notice or patient-facing notice that this is an institution that sells de-identified data sets, maybe those are good ideas, and maybe they don't even sound that hard. But one, it creates a different standard, right? So there's no longer now a federal standard. Now, when you're trying to free up de-identified data, you have to think about the federal standard, and you have to think about California. So it introduces complexity. And in addition, I'm going to talk specifically about these contractual requirements. Those contractual requirements, depending on the contracting environment, it can be actually quite expensive to do because it involves multiple contracts, negotiations, and sometimes not so much control or the ability to audit what happens downstream. Now, again, I'm not saying these are bad things. Protections against re-identification are probably a good idea. But how that's done and doing it on a state-by-state basis is going to make things harder, not easier. Now, in terms of, so really, where am I driving here? I think that the HIPAA de-identification standards are pretty good. They work pretty well. And the greatest thing about them is that they're standardized. And they've been in effect for decades, and the industry itself has adapted. So can we have, and maybe we need to revisit those federal standards, that's okay too. So maybe the answer here is to revisit the federal standard and have some kind of preemption, although that is you say that word and there's fireworks politically. But I do think that a federal standard, a clear standard that is perhaps updated, is going to help free up a lot of data for these uses.
Yeah, as I heard many of the things you were mentioning, the consumer notification, actual penalties for re-identification, contractual obligations, it does sound quite reasonable from my perspective. And so that, when I think about what California is doing in terms of car emissions, and I wonder whether this is going to have the same effect of really moving the whole field in the right direction. But I also recognize many of the concerns that you mentioned and how that could stifle innovation by parties. Do any of the panelists have any comments or follow-up questions for Marzyeh?
So you know me, I'm always going to have a question for one of the panelists here. So Marzyeh, the FDA has already staked out ground to say that software as a medical device, including AI-driven algorithms, is something that's within their regulatory purview. The problem is that the definitions of clinical investigation and research are different for the FDA compared to HIPAA. And so there is no de-identification exclusion for FDA regulated or research that's done in support of regulatory decision making. So I'm just curious, how do you see that playing out as we have both the FDA saying AI and software as a medical device is something that's within our purview, but they don't have this de-identification exclusion that HIPAA does?
So a couple of things on that. So the FDA, as you say, has asserted their jurisdiction here. They have issued sort of a risk-based enforcement discretion, right? So they want everyone to be clear, we have jurisdiction here, but we want to kind of let things grow. And so if it's not too risky, we're not going to enforce. And so in terms, but where you are governed by the FDA, where this is going to be a medical device, there's a regulatory framework in place, right? Which is to say, if you're regulated, you have to, and you're doing research, you can, for de-identification, the privacy issues are really addressed through either an IRB approval and consent or through an IRB waiver, right? There's a mechanism. Or if it's not, let me leave it there, which is to say, I think there are other tools and pathways available for when you are regulated by the FDA, and you would use those and not so much the de-identification pathways. Does that make sense?
Mm-hmm.
Thanks. Go ahead, Ed.
Yeah, Marzyeh, just to kind of follow up, I think one of the most interesting things I found out in the forum when we got together last time was actually the case of Mimic, and the fact that, in 30 years of having that data, didn't have a single re-identification issue. And so, although I'm in no way minimizing, the importance of de-identification, I also at the same time am just wondering, this is always a conversation that we discuss, and it's something that prevents innovation in a huge way. But is it really the stumbling block? Or is actually the issue that people aren't really understanding exactly what's going to happen with their data, and so are not incentivized to legislate or create policies from kind of a more positive intent? If I take some of Anna's examples of some of the upside issues. So is there a case here that actually as technology improves, as security improves, that we will see the conversation instead of changing from defensive to more positive?
Maybe.
So you're suggesting that as the technologies get better, I want to make sure I'm understanding your question. It's as the technologies get better, both the identification technologies, the generation of synthetic data, and the like, maybe some of this will be solved. And I think the answer to that, on the one hand, is yes. And I think we are going to be seeing more and larger synthetic data sets. I think that Google and Anthem just announced that they were going to enter into a partnership around creating a large synthetic data set. So, but I think there are two issues. One, it always seems to take longer than we think, as is evidenced by the fact that, Mimic is kind of alone over the past decades in terms of that big available data set. So it must be harder than it looks. And two, even when we talk about synthetic and de-identified data, I think that we want to be clear on what part of the problem or what part of the challenge does this solve? And yes, we're going to get better on that front. And there always seems to be some larger world where it's not good enough, right? It'll take you so far in terms of developing your algorithm, and then you gotta go on live data at some point to tweak it and refine it. So yes and no is the answer.
I wanted to quickly say in response to that one of the things that we found repeatedly in many different studies is that synthetic data does not work very well, specifically in health, because it often abstracts, obscures, or removes important information, specifically from minority patients. And so I think we want to be really sure that when these large companies, which are used to maybe de-identifying or making synthetic versions of data sets from billions of users who are typing texts or doing search, it's a little bit different to get, a synthetic data set in that setting. Billions of people, you mispredict a text and that's fine. Wrong to saying, I can't predict your diabetic risk because in a synthetic data set, I didn't have very many Black women. And so one of the things I've really struggled with is Mimic is alone, but it's not alone for necessarily technical or potentially legal reasons. It's maybe alone for social reasons or political reasons where people don't want to share data when they're not sure they'll get the appropriate IP recognition from it, or they think they can monetize their data by de-identifying it and selling it to Google or Amazon or Microsoft. And so there's less of an incentive. And so I think really focusing on aligning some of those incentives is quite valuable because, we as academic researchers are sitting here potentially looking at a future where private companies own all the de-identified health data because they can pay for it. And we're not in a position to audit, train, or evaluate anything they put out.
So just for the audience, the word Mimic has come up several times today. Mimic is referring to a data set released by the MIT Laboratory for Computational Physiology, also known as PhysioNet. So if you search for any of those words, you'll find it. Go ahead, Jonathan.
Yes, I just following up on Elliot's point. I'm sort of half with you in as much as I think that the technology does enable a better set of security sort of solutions to be there. But equally, I think it sort of does also provide some issues as well, because I think the greater technology in the hand of some participants in databases, the more they can in a way serve to re-identify themselves. I mean, I am taking Doug's point, he's quite absolutely right. Just by leaving your genetic sequence, unless you've got a sampled reference, it's not going to identify you. But if you've been a bit careless in some ancestral databases, that starts to become a slightly more sort of nuanced discussion. And also just to say, I think with the regulations, they're never going to be ideal. No one's ever going to regulate in a way which actually makes it all work out. It's just to make sure they're not actually obstructive to actually trying to do some of this. And really with the contracts, I think you need that sort of contractual restriction on researchers not to try to do this. But at the same time, the main incentive on them is reputational. In other words, whatever contract they actually sign up to, the real issue is if they were found to be trying to re-identify participants in a database when they specifically have been told not to, it's a serious reputational problem I think they'd have to encounter.
Right, so I'm going to bring in some of the audience Q&A questions now. So Colin asked whether informed consent is something that's even feasible when we're talking about clinical data sharing, perhaps even de-identified data sharing. Do the panelists have any thoughts on that?
I think we talked briefly about informed consent in one of the sessions, and we all agreed that it was an incredibly complex topic, even without some of the issues we're talking about. And so I do think one of the few things that we all agreed on was that trying to have a model where you really engage with people within the community and with bioethicists who are focusing on how you phrase questions so that there is a better understanding of what is actually being consented to is an important area of research and engagement for data set collectors and users moving forward, but it's an open question.
I mean, I think that there are absolutely use cases where the informed consent model works and can work well. It's also the case it's very hard to do at scale because the data sets get very quickly biased. And there are other challenges. I mean, the All of Me, All of Us initiative at NIH is trying to move forward. Again, a quite large data sharing initiative at scale with a consent model, and it's very slow going. It's yet to see if that's to be successful at the scale that they would like.
So I'll stop us there to get a quick pace of new questions coming in. So we've been having a really US-centric conversation so far. What about what's going on in data outside the United States, whether it be in more developing environments and nations or other resource rich settings? Any thoughts? Or first of all, what has the panel been seeing in terms of health data sharing for the purpose of health AI research outside of the US and outside of the UK, which we've already spoken about, and specifically with regards to developing nations? Go ahead, Jonathan.
Just to say anecdotally, and the conversations that we've had with various sort of bioresources and biobanks really from around the world, they seem to me to be grappling with almost exactly the same questions of sort of data identifiability, access, and sort of and similar. I mean, whether it's in Asia, South America, Africa, Australasia, or or Europe, I do think there's a very strong theme with all these issues. There's no, in other words, that North America's not out on its own here. It's very much in exactly the same sort of group setting as everybody else. I've got no statistical backup for that, I hasten to add, but just that's just an observation.
Other thoughts? Go ahead, Anna.
Also, again, anecdotally, I was sort of blown away by friends in this space that has said, so I was going to comment actually to Marzyeh's comment that in France, they went away from the full informed consent or trying to scale it up to say that any data access that will be served to improve the healthcare of the full population can be granted data access. And so this is this was France's response to GDPR and sort of every individual having to consent or remove their own data from being used from big public sort of data collections. This was said that we believe that it's an important access point for making healthcare better, and thus this data can be accessed in this fashion under this sort of regulation of betterment for the society.
But how do we bring health AI advances to parts of the world which don't today have well-established electronic medical records or health insurance companies that aggregate high-quality data across large numbers of people?
So there are such examples, right? In our upside presentations, Regina's example said they've deployed in Brazil, which is not the lower income, but the middle, I guess, income country, and several other countries around the world. The Stanford's I believe the eye, the retinopathy, right, detection, that was implemented first in the clinics in India. So we can say that they don't have it, but maybe they have leapfrogged the technology and we are stuck with something that is more legacy than what they're building right now. I don't know if this is the case, but there are definitely examples of this already.
Thank you, Anna. Go ahead, Elliot.
Yeah, so I think this will come more from the private sector than anything else. If you look at two nations that have been pretty good about, giving multimodal patient longitudinal data, it's probably Israel and India. And actually, the one anecdote you can say is that if you look at clinical AI companies that have at least got close to achieving kind of deployment in US healthcare settings, overwhelmingly they're Israeli based. And so that at least just shows you some of the advancements, certainly on the private side, that you can enable once you give people the access to correct data. David, your point on how do you then deploy, or how does AI then help developing nations, I kind of want to split into two aspects. There's one, which is how do you train models appropriately with the right kind of data, since you can't necessarily collect it. And then the other problem is, well, how do you actually deploy them, since you haven't got a healthcare system that is as well infrastructure. But I think the problem is we're not even at the training part of necessarily some of those countries. So I would kind of definitely start there in terms of data collection, or adjacencies or corollaries that we could use instead.
Okay, thanks for the very thoughtful answers so far from the panel, and for the excellent questions that we received on the Q&A. I want us to close out today's conversation with one or two final questions, starting with asking what data is the community not currently doing research on as a whole, the research and development community, whether it be in academia or industry, that we should be prioritizing. One thing that came up in our wide reach sessions was, for example, web search data, where patients might be going to a search engine and looking for symptoms, for treatment advice. Also social media data, where particularly when you think about depression and other conditions, some of the opportunities for intervention, in addition to better understanding of the current prevalence in the world, might be found in social media data. How should we think about research on that outside of the companies that own that data?
I guess I'll go again, although I realize you've heard a lot of my voice recently, so I apologize, but you happen to be hitting topics I've thought about. I would actually almost start with some of the most basic stuff, which is, and this Doug will appreciate more than most, is how do you append some of the data that exists to some of the more basic clinical records, which is really how one of the biggest issues is obviously the data silos. So just saying, how do we look at social media data? How do we look at wearable data? How do we look at this? How do we look at that? Outside of joining it to some of the more relevant clinical data, I think will just get you into the same problem we got into before. So I'm more interested in how do we start combining that. Where we start, I wouldn't have a strong view, but the infrastructure to make that possible, I think, is important.
We'll go to Jonathan and then to Marzyeh.
I just entirely agree with that, because I think that the real thing which a lot of resources and lack is actually proper access to proper health records. Because if you don't get that, you can't actually run a proper prospective resource. You can't run a clinic. You can't run a clinical trial. You can't validate anybody's health outcome. And I'd very much start there, because that seems to be an absolute building block for all this research. And the latter stuff is a bit of a nice to have, but that's the key bit.
I think that another thing you can think of is not just the modality, but also populations that maybe have been traditionally excluded. It wasn't until the 1990s that the NIH required women be included in medical research. And even now, there was a study in 2019 that found that only 13% of NIH-funded trials performed subgroup analyses that were mandated by the 1993 law. And this is just, most studies are industry funded, where these mandates don't even apply. And so, this is a non-binding recommendation. And so I think having these other areas where you can collect data from a much larger, more diverse population, maybe can help to balance and redress some of these known inequities in the data that we currently have and collect.
Go ahead, Doug.
Well, I just wanted to just put a little bit of the conversation in perspective. In 2010, 17% of all doctors used electronic health records, and maybe 20 or 30% of all hospitals did. 12 years later, nearly every hospital in the country uses electronic health records, and probably 85% of all physicians do. So I think this gives me some hope, because we are really early on our journey in using health information at scale with all of the privacy concerns and things like that. I would agree with the panelists that the most important data to get access to is that clinical information, laboratory, genomic, all of the things that are central to health. And then there's sort of the penumbrum around that, the other data, the ambient data that is out there that has an impact on health as well. But I'm optimistic because we are early in the journey. It took 25 years for the financial industry to get to the point where ATMs worked worldwide. We're only halfway there. And this is a much more complicated, much more difficult problem to solve. But we've got lots of good minds on this panel and in the wider range to make a difference.
And with that, I think that was the perfect place to end our session today. So thank you so much, Doug, Jonathan, Elliot, Anna, and Marcy for joining us here today. And we look forward to the rest of the sessions.